Hey guys, Mr. Mailhot here, coming at you from, well, this is my office at my house, so welcome on in. It's Tuesday. I hope you had a great weekend. We're going to continue our work with Unit 2. We're almost done, but before we get going, number one, you need to do a check-in, so we'll do that in a second. You also need your binders. So, when I tell you to, pause the video, make sure you got your binders, and then do a great check-in with your group. Tell them something good that's going on, all right? Binders, check-in, go ahead. All right, let's get going. We're going to continue with equations today. We're going to do 3 tasks together. Task 9, Task 10, and Task 11. And then the remaining time of class, you'll do Task 12, and we'll discuss next time. Excuse me. Your learning target today is how does a constant in an equation affect the solution? And success criteria is that you can solve an equation for a given variable. All right? Let's get to it. Please turn to Task 9. Task 9. Let's read through the directions together. Task 9. How does the solution change? The equations A through D, the solution x to the equation depends on the constant a. Remember, I think we talked about what this word constant means before. It might have come up. It just means a number. So the solution depends on some constant. We're going to deal with just a being positive, and we're going to answer this question. What is the effect of increasing a on the solution? Does it increase? Does it decrease? Or does it remain unchanged? Give a reason. You know we give reasons in this class. Without necessarily solving. So we're not really solving, and we kind of can't because we got 2 variables in one equation. Here's what I want you to do. Try different values for a. So what would happen if a was 0? What if a was 1? What if a was 5? What if a was 10? Like, you don't have to use those numbers, but pick numbers and see what would x have to be. What would x have to be if you changed the value of a? All right, if you increased it. So there's 4 problems. Let's say 12 minutes. So look at the clock. 12 minutes. Pause the video. We'll come back and we'll go through answers. All right? 12 minutes. Get to work. All right, let's go through answers quickly. We're not going to go as in depth as we normally would just because I got a time limit for the video. So here we go. For the first one, what I would hope to see is something like this. As a increases, x, for this one, also increases. As a increases, x also increases. Now, why is that for this one? Well, think about the properties that are going on here. You got 2 things that you're subtracting from each other, and they're equal to 0. And the only way that happens is if those 2 things are the same. So if one of them gets bigger, the other one's got to also get bigger, so when you subtract, you get 0. For B, as a increases, x decreases. This is kind of interesting. But again, think about the properties that are being shown. Like, let's just say a was 10, and we know it's got to equal 1. Well, what would you have to multiply 10 by to get 1? 1/10. And if a was 2, you'd have to multiply it by a half to get 1. If a was 7, you'd have to multiply it by 1/7 to get 1. I think you see a pattern. But x gets smaller, like let's highlight it. X gets smaller. It becomes a fraction. It's a reciprocal. For question C, as A increases, X, oh, this one was cool. This one was kind of cool. Remains unchanged, or it stays the same. Now, why does it, I'm sorry about my handwriting, by the way. Why does it remain unchanged? Look at the equation. This one's pretty cool. Yeah, AX equals A. Well, if we wanted to actually solve, even though we weren't really asked to, we'd divide by A and divide by A, and you got X equals 1. And when you multiply 1 times something, it doesn't change. And actually, that's the only way it wouldn't change, is if X was 1. For the last one, as A increases, turning the page on my answer key, as A increases, X also increases. As A increases, X also increases. This one's related to the first one. It's not that we're subtracting, but we're dividing by the same thing. And the only way you could divide something by something else and get 1 is if those two things were the same, right? And so if you're making one of them bigger, the only way to still get 1 is if you make the other one bigger. If you make it bigger in the exact same way. Yeah? All right. Turn the page. Let's go to task 10. Headphones. All right, task 10. We need to do a little setup and then I'll let you work. A store sells 2 brands of headphones, HD and basic, and buys them at different dollars, X, Y, Z. We got a bunch of variables going on. The goal is write an equation whose solution is the given quantity. We're actually going to do the first one together, and then I'll let you do the other 2, all right? But in order to do that, we need to set up an equation first for this entire situation. So we have some variables given here, right? X is your HD headphones. Z is their price for HD. Y is your basic headphones, and W is the price for those basic headphones. So if we wanted to calculate the total spent on all the headphones, wouldn't it be the HD times how much those cost, plus the basic times how much those cost, right? HD and basic times how much they cost. Maybe like the number of HD and basic bought. Well, let's use the variables. The total is going to equal HD, which is X, times HD headphones price, Z. So X times Z, X times Z, plus the basic headphones, the number of basic headphones, Y, times how much those cost, W. This equation you will use for each problem, all right? And replace stuff based on what they give you. Let's do A together and then you can work. A says the number of basic headphones the store, we want to find, like maybe start this. Want to find the number of basic headphones the store can purchase if it spends a total of $10,000 on headphones altogether and buys this many of HD at that price. Use this equation and fill in what we know. What's the total that they spent? 10,000. Replacing T, 10,000. Now, HD headphones, is that X or is that Y? Which one was that? It's X, right? So instead of X, we'll write 110 times the cost times Z, but they gave us a value, like here's X, they gave us a value for Z, times 70. Let me make that cleaner, times 70. Plus, do we know what Y and W are? No. We don't know how many they bought, and we don't know how much they cost. But that's what we're being asked to find. We want to find the number of basic headphones. Now, is W the number or is Y the number? Y, right? It was Y basic headphones. So our eventual equation, we want to have it say Y equals something. We got to do a little scratch work. Well, if you multiply this, you'll get 7,700. So if we subtract 7,700 from this, these will cancel out. We got to do it to both sides. Oops, 7, giving us over on this. I did the work over here. 2,300 equals YW, right? Those canceled. We subtracted over here as well. Well, shoot, how do we get this to just be Y? Divide by W on both sides. So 2,300 divided by W. The number, like, think about what this means. The number of basic headphones you can buy is $2,300 divided by how much each one costs. You have $2,300 left to buy as many basic headphones as you can. All right. Try B and C using this. Let's highlight it. Using this equation, filling in what you know. These are a little more challenging. So let's say 10 minutes, okay? Come back in 10 minutes, and we'll go through answers for B and C. All right, 10 minutes. Go ahead. All right, we're back. Let's just put the answers out there. You guys can discuss how we got there. All right. For B, you wanted to find the price of HD headphones. Well, the price was Z. And if you manipulated stuff, plugged in the stuff right, solved for Z, you should get this. Z equals 900 over X. And for C, you wanted to find the number of HD headphones. That was represented by the variable X. How many headphones? And based on the other information they gave you, you should have come up with 6,300 divided by Z. If you got those, that's awesome. If not, while we work on the next task, maybe go back and look and discuss and see if you can work backwards to get to those answers, all right? We're almost there. Turn to task 11. Task 11 really gets at the heart of what your exit ticket is today. We're going to go quick. Use inverse operations. Well, inverse operations, that's just like multiplication to division, addition, subtraction. You guys know how to undo things. Use inverse operations to solve for the unknown variable or for the designated variable. If there's more than one operation, think carefully about which one you can do. You'll notice that, like, for the first ones, the problems are very similar. So for A, you just add 3, and you got A equals 2. Question B is different but related. Solve for A. Well, that means we want to have A equals. Well, how do you get A by itself? Well, add B to both sides. Those cancel. You can't add C and B and get one thing, so you just write C plus B. All right. Go through the rest. There's several problems here. So let's say 18 minutes. All right. Look at the clock. Come back in 18 minutes. I'll have the answers up here. We'll go through them real quick. All right. 18 minutes. Go. All right. We're back. Here are the answers. If you want to check them, go ahead and pause the video and check all your answers. All right. If you're stuck on some of these or you're unsure, put a star by them and we'll talk about them next class, all right? And always, you can go back and look at this video. It's on our Google Classroom too. So here is your exit ticket, all right? The formula for finding a cylinder is right here. Sorry, right here on the bottom. Solve it for H, so H equals something. And then if you solved it for R, what would that be? Don't do it. I mean, you can if you want. But if you did, what would that mean in the context of this problem, all right? Do your exit ticket. If you have time left, work through task 12. We'll talk about it next time. I miss you guys. Hope to see you at student-led conferences. See you later. Bye.